Okay. Good morning, all. Welcome to the Geology Lab session. I'm Dr. Chandrasekhar Pagsnalli, Assistant Professor, Department of Civil Engineering, BMSIT of Technology and Management, Bangalore. Today we are going to discuss about the thickness problem, and especially in the last sessions we discussed about the type 1 and type 2. Now we are going to discuss about the type 3 problems and thickness problem. So all we need to do here, we are on a horizontal tunnel, a bed of sandstone dips 30-degree eastern side toward east, and its true thickness is 200 meters. You already given a TT here. Determine its vertical thickness and width of the outcrop in the tunnel. So all we need to do now, we need to draw this what to call this ground surface first, and we are giving the and a dip amount and directions. Direction is eastern side. We are giving the dip amount and we are giving the true thickness here. So you need to draw this, these two width of the outcrop. Okay, you need to calculate this. So from this point, from the B point, we are giving the true thickness here. We are giving the true thickness here from the B point, and you need to draw the perpendicular of this. That's about 200 meters. That means 2 centimeters. And perpendicular to this ground surface, you need to draw this. It's a vertical thickness. So you join this, you draw the line of this contact, 2 centimeter and all it. That's called the lower bedding planes. Wherever it cuts, it is called your vertical thickness. Okay, true thickness already given. That's a 2 centimeter. Draw this line perpendicular to this upper bedding planes, parallel to this, and you draw the upper bedding planes. Thus you will get it. Okay, that's already there. That's the 30 meters. So now, mathematical methods. This is all about the graphical method. Measure the vertical thickness distance. That's about 240 meters. That's called 2.4 centimeter. And width of the outcrop is 400 meters. Mathematical method, TT is equal to VT multiplied with the cos theta. True thickness is 200 meters. This is already given. VT is there that we need to calculate. Take out this 230 minus 94 meters. So VT is equal to W tan theta. So VT, we know this already. We calculated here 230.94. That's equal to W tan 30 degree. Okay, this our width of the outcrop is 400 meters. So here graphical method as well as in the mathematical method, both are same here. The answer should be the same like this. Okay, and here 230 meters vertical thickness, but here how much you are getting here, and here it is a 240 meters. So 10 meter difference is there between graphical method and in the mathematical methods. That should be the minimum, actually 1 or 2 centimeters, but it should be the accurate, it should be the same. So now this is let's go for the type 4 problem here. In type 4 problem, we are giving the data, vertical thickness, dip amount and dip direction. All we need to do, we have to calculate true thickness and width of the outcrop. This is a type 4, and here is the borehole, or this is a problem, thickness problem. Borehole is sunk on a level ground and encountered the upper bedding plane of coal seam at 110 meters, lower bedding plane at 230 meters on the surface of the coal seam, and it's dipping at 30-degree angle towards east, and find out its true thickness and its width of the outcrop. Scale you need to take it, 1 centimeter is equal to 100 meters. Okay, so all we need to do, so draw a ground surface first, mark the A point. What are the things we have given here? Mark this first, the A point, and here we are giving the vertical thickness of the first, or you can mark the B point first. Okay, and from this B point you draw the vertical thickness. How much is the vertical thickness here? This upper bedding plane of this 110 and lower bedding plane is 230. 230 minus 110, so you will get So okay, so here you need to draw this ground surface and B point, mark the B point, and you can draw the the bedding planes by using the 30-degree angle towards east. Draw this line, and you can draw this the upper bedding planes and lower bedding plane contacts to 230 minus 110, and you'll get 120. That's called 1.2 centimeters here. Okay, this is a vertical thickness of the bedding planes. By using this contact, you can perpendicular to the upper bedding planes, you can draw the lower bedding planes, so that you will get this another point called A. That's called your width of the outcrop. From A to B, this is your width of the outcrop. Okay, and that's called a 210 meters. That's all, you got it here, 210 meters, and true thickness is 110 meters. This is perpendicular to the upper bedding plane. You draw it and measure it so that you will get 110 meters. So let's go to the mathematical method here. So in the mathematical method, this is a very easiest way, and Vt is equal to W tan theta. We know the W value here. Okay, or you can calculate W value here. That's in graphical method, but in mathematical method, W is equal to Vt by tan theta. We know that Vt value, that's the upper bedding plane and lower bedding plane contact. If you subtract it, you will get 120 meters, and tan theta, theta is the angle of inclination of the bedding, that's 30 degree, and this is 207.84 meters of the width of the outcrop. And true thickness, when you are going to calculate the true thickness, that's a formula Tt. Tt is equal to Vt into cos theta. We know the Vt value here. Okay, 120 meters multiplied with the cos theta, an angle of inclination of the bedding plane, and altogether we'll get true thickness is 103.92 meters. This is all we need to calculate. This is how we need to calculate the thickness problem by using the graphical method as well as the mathematical method. There are 4 types of problems in thickness problem taken. Okay, this is all about the thickness problem. Thank you very much for this session. Thank you all.